Welcome to this explainer. Today, we're jumping right into a wild story. We're going to explore how the modern artificial intelligence revolution, well, it actually wasn't born in some sterile, top-secret corporate lab. No, it started in a smoky California tavern back in 1972. It's an incredible story that bridges the gap between a single bouncing pixel of light and the insanely complex cognitive systems that are defining our world right now.
So how would a plastic coffee can, stuffed to the brim with quarters in 1972, lay the absolute foundation for today's AI revolution? Let's dive right into this mystery. We're going to trace this bizarre butterfly effect, one that kicks off with a machine that completely, fundamentally shattered the way we as human beings engage with electronic screens.
To really get this, you have to picture the electronic landscape of the early 1970s. It was entirely about passive consumption, right? You had the television, which was strictly a one-way broadcaster. It just sat there, and you just sat there, trapped in this sedentary reception. And on the flip side, you had computers. But these were elite, incredibly intimidating, calculating instruments, totally locked away in corporate data vaults. The very idea of a normal person physically interacting with a screen? Honestly, it was virtually unthinkable at the time.
But then along comes Atari co-founder Nolan Bushnell. Bushnell completely threw out the traditional academic computer science dogma. You see, unlike the PhD researchers down the road at Stanford, Bushnell was an engineering grad who had spent his summers working as a carnival barker at an amusement park. Seriously. And he brought that exact carnival matrix into computing. Instead of focusing on abstract, complex calculations meant for elite specialists, he wanted direct, visceral amusement. He wanted tactile controls, like physical potentiometer knobs. His goal was to democratize access and bring technology straight into the public tavern where everyone could play.
But Bushnell realized that if you're going to actually convince a consumer to part with their hard-earned quarter, you need a precise triad of design. First up, an absolutely minimal learning curve. I mean, you had to understand the game instantly, no manual required. Second, you need this illusion of mastery. The game had to invite casual play, sure, but with dynamic difficulty that challenged your competitive ego, literally pushing you to feed in more coins. And third, a high-density social spark. The machine couldn't just be a game, it had to be a theatrical spectacle that drew a massive crowd.
Now, turning that triad into a physical reality took some massive ingenuity. Bushnell hired this brilliant, self-taught engineer named Alan Alcorn to build Pong. Now, using traditional computing at the time, this would have cost thousands of dollars per unit. No way that works. So Alcorn optimized the hardware in a mind-blowing way. 0 microprocessors, 0 software code, and 0 memory. He built the entire game logic using just 75 cheap, off-the-shelf digital chips.
What Alcorn essentially did was industrialize computation. He hardwired timing voltages directly into the synchronization pulses of a standard, cheap black-and-white television set. Players use simple potentiometers, rotating dials, to alter the voltage and move their paddles. He even segmented the physics of the electronic paddles so the ball would bounce off at these high-velocity angles, and he threw in an oscillator to create that iconic metallic ping sound. And the craziest part? He produced all of this dynamic, interactive physics for under $100 a unit. By September 1972, it was time for a field test. Bushnell and his team hauled their crude, yellow-topped prototype just down the street into Andy Capp's Tavern in Sunnyvale. They hooked the whole thing up, routed the coin mechanism straight into an empty plastic Folgers coffee can, and left this beautifully minimalist instruction taped right above the screen. It just said, "Deposit quarter, avoid missing ball for high score."
That crude little prototype, it instantly triggered an uncontained behavioral contagion. I'm talking within 48 hours, local patrons were lining up outside the door at 10 a.m., just continuously feeding quarters into the slot until closing time. It completely sucked the tavern's energy away from the predictable, sedentary mechanics of traditional pinball tables. Suddenly, everyone was plunged into this intense, high-velocity digital competition. And it gets better because just 2 weeks later, the tavern owner actually called Atari demanding they come remove the machine. He reported a total breakdown. But when Alan Alcorn arrived and reached inside the cabinet, he made a shocking, honestly hilarious discovery. The machine wasn't broken at all. The economic velocity had been so immense that the plastic Folgers coffee can inside had completely overflowed with quarters. The market had literally thrown capital at this machine until its physical infrastructure just jammed up.
Faced with this explosive success, Bushnell flat-out rejected the idea of licensing Pong to the traditional amusement monopolies back in Chicago. Instead, he made a radical gamble to build his own mass-production factory. He rented out a massive, vacant roller skating rink on the pier and built this high-velocity, completely countercultural assembly line. This was nothing like the sterile semiconductor cleanrooms of the era. Atari recruited high school dropouts and anti-war activists, running round-the-clock assembly shifts with blaring rock music and open solder pots. It was total chaos, but it worked.
Despite that incredibly chaotic environment, Atari pulled off an absolute miracle of mass production. They successfully churned out over 10,000 finished Pong cabinets, shipping them globally to taverns, airports, arcades, you name it. In under 24 months, their revenue absolutely skyrocketed from $0 to $3.2 million. That move permanently established the West Coast as the ultimate command center for consumer physical hardware.
Now you might be thinking, okay, cool story about a retro game. But this single hardware breakthrough wasn't just some gaming fad. It established a direct, unbroken mathematical continuity. From the analog timing gates of that 1972 prototype all the way to the massive artificial intelligence networks we have today, the underlying relationship between human play and the interactive screen has remained incredibly consistent.
Here is where it all connects. To process the really complex graphics required by later home consoles like the Atari 2600, engineers had to develop highly specialized graphics hardware. And that necessity directly led to the founding of NVIDIA in 1993. NVIDIA realized something absolutely profound. The massive parallel vector calculations needed to simultaneously render millions of 3D video game pixels, they are mathematically identical to the calculations required to train advanced artificial neural networks. Today, the modern cognitive AI era runs entirely on hardware architecture originally funded by our basic desire to play video games. Mind-blowing, right?
But wait, this connection actually goes even deeper into the software itself. Bushnell's original game designs provided the literal computational training grounds for machine intelligence. Back in 2013, Google DeepMind achieved a massive computer science breakthrough by teaching an AI to learn autonomously, achieving superhuman mastery. And the testing field they used for this? The classic catalog of Atari games, like Breakout. The AI learned purely by interacting with the screen pixels, proving that those 1972 design rules were perfectly scaled for machine learning. We even see this whole story echoing in the cultural geography of today's tech landscape. The current generative AI wave has kind of shifted away from the quiet corporate parks of Sunnyvale and moved directly into the dense urban grids of San Francisco, an area everyone's now nicknaming Cerebral Valley. Modern founders are planting their hacker houses in repurposed industrial buildings, specifically to foster that rapid, intense, cross-pollinating energy. It's a direct, modern-day echo of Atari's countercultural assembly lines back at that vacant roller skating rink.
Which brings us to our final takeaway. Atari didn't just invent a commercially successful arcade game, they broke the ancient tyranny of the passive screen forever. So, as we wrap up this explainer, I want to leave you with a thought to ponder as you interact with the very digital matrix you're looking at right now. Think about it. How much of your digital reality today, from the interfaces you use daily to the incredibly complex AI models working behind the scenes, is running on an architecture built entirely on the simple human desire to play?